Everything in existence has an expiration date. Your carton of milk, your car, the planet Earth, the stars in the night sky, and eventually, the universe itself. Since the dawn of humanity, we've been obsessed with how the world will end. But for a long time, scientists debated exactly how the entire cosmos would die. Would it be the Big Crunch, where gravity pulls everything back together into a super dense, unimaginably hot fireball? Or maybe the Big Freeze, a slow, agonizing process where the universe just keeps expanding forever until all the stars burn out, the black holes evaporate, and everything goes completely cold, dark, and silent. Both of those sound pretty terrible, but recently, theoretical physicists have been studying a third option, and it is, without a doubt, the most violent, terrifying, and awe-inspiring apocalyptic scenario ever conceived. It's not a slow freeze, and it's not a fiery crunch. It is a shredding, a literal, physical tearing apart of the very fabric of reality. Scientists call it the Big Rip.
To understand how the entire universe could rip itself apart, we first have to understand the invisible war happening all around us right now. Think of gravity as the ultimate cosmic glue. It's the force holding your feet to the floor, holding the moon in orbit around the Earth, and holding billions of stars together to form the Milky Way galaxy. Gravity's entire job is to pull things together. Even Albert Einstein believed the universe was a static, stable place held together by this cosmic glue. But almost a century ago, an astronomer named Edwin Hubble looked through his telescope and realized something deeply unsettling. The universe isn't sitting still, it's expanding. Every distant galaxy is flying away from us. For decades, scientists assumed that the combined gravity of all the stars, planets, and black holes in the universe would act like a giant bungee cord. Sure, the universe was expanding from the initial explosive force of the Big Bang, but eventually the collective bungee cord of gravity would stretch out, slow the expansion down, and bring things to a halt. It made perfect sense. Until 1998, when astronomers measured the light from distant dying stars called supernovas and realized the math was completely, horribly wrong. The expansion of the universe wasn't slowing down, it was speeding up. Imagine throwing a baseball straight up into the air. You expect it to slow down, stop for a fraction of a second, and fall back into your hand. Now imagine throwing that baseball and instead of slowing down, it suddenly hits an invisible gas pedal and rockets upward into space, moving faster and faster the higher it goes. That makes no sense in our everyday lives, but that is exactly what the universe is doing. And the culprit behind this terrifying acceleration is something scientists call dark energy. Dark energy is the most mysterious and dominant force in physics. We can't see it, we can't touch it, and honestly, we don't really know what it is. But we know it makes up roughly 68% of the entire universe. If gravity is the cosmic glue trying to pull everything together, dark energy is the cosmic wedge trying to push everything apart. And here is the truly mind-bending part. Dark energy seems to be a property of empty space itself. As the universe expands, more empty space is created, and because there is more empty space, there is more dark energy, which causes the universe to expand even faster, which creates even more space, which creates even more dark energy. It is a runaway cosmic train, and the brakes have been completely cut. Gravity is losing the war. In the standard model of physics, dark energy pushes space apart, but it's relatively weak on a small local scale. Gravity is still strong enough to hold galaxies and solar systems together, just like a sturdy wooden raft holding together on a stretching, turbulent ocean.
But what if dark energy doesn't just stay constant? What if its density actually increases over time? This is where the Big Rip theory comes in. It introduces a terrifying mathematical concept called phantom dark energy. Think of blowing up a balloon. Normally, the more you blow into it, the thinner and weaker the rubber gets until it pops. But phantom energy is like a bizarre, physics-breaking balloon, where the more you inflate it, the thicker and stronger the rubber gets. If dark energy continually grows more powerful, the expansion of the universe won't just stretch the empty space between galaxies. The expansion will eventually reach infinite speed. And when that happens, dark energy will become strong enough to rip apart the wooden raft. It will overpower gravity, then electromagnetism, and finally the strong nuclear force holding your very atoms together. It is the ultimate cosmic unraveling, and theoretical physicists have mapped out exactly how this final apocalyptic timeline would unfold. Let's fast forward to the end of time. T-1 billion years before the rip, the speed of the universe's expansion has become so extreme that the cosmic horizon, the edge of what we can possibly see, begins to shrink rapidly inwards. Massive galaxy clusters, the largest structures in the universe, are the first to be torn apart. The gaps between galaxies become so vast so quickly that light can no longer cross the distance. T-minus 60 million years before the rip, the night sky changes forever. The repulsive force of phantom energy is now so strong that the gravity of the Milky Way can no longer hold itself together. The outer edges of our galaxy are peeled away like layers of an onion. The beautiful, swirling spiral of stars we've lived in for billions of years scatters into the dark. We are officially isolated. T-minus 3 months before the rip. Gravity on a local scale completely fails. The sun's pull is no longer strong enough to hold on to its planets. Earth, Mars, Jupiter, all of them are violently ripped out of their orbits. The solar system is disbanded. Earth drifts off into the freezing black void alone, moving away from the sun faster than the speed of light. T-minus 30 minutes before the rip. Things get intimately, violently personal. The dark energy is now so incredibly dense that the gravity holding the Earth itself together is overpowered. The planet begins to rumble, the crust cracks open, the oceans boil into space, and the Earth simply shatters into billions of floating boulders, magma, and dust. T-minus a fraction of a second before the rip. At this point, there are no planets, no stars, and no galaxies, just scattered lonely debris. But the shredding isn't done. Electromagnetism, the force holding molecules together, fails. The very molecules that make up water, rocks, and the human body are ripped apart into individual, wandering atoms. T-minus 0 seconds. The Big Rip. In the final, unimaginable fraction of a nanosecond, the phantom energy becomes infinite. The strong nuclear force, the strongest force in the entire universe, is completely overcome. The atoms themselves are ripped open. Protons, neutrons, and electrons are shredded into subatomic nothingness. And then, space and time themselves break. The fabric of the universe is stretched infinitely, tearing reality into a state where distance, scale, and time no longer mean anything. The universe doesn't just empty out, it literally ceases to be a place. If this just gave you a massive existential crisis, take a deep breath. Even if the Big Rip is our ultimate fate, the math suggests it won't happen for at least another 22 billion years. You don't need to cancel your weekend plans, and you still have to pay your taxes. But thinking about the Big Rip gives us something incredibly valuable: perspective. We exist in a perfect, temporary, beautiful Goldilocks window of cosmic history. We live in a time when the universe is calm enough for stars to shine, for planets to form, and for life to evolve, look up, and wonder how it all works. We get to see other galaxies. We get to feel the warmth of our sun. One day, billions of years from now, the lights will go out and the stage will be violently torn down. But right here, right now, the universe is holding itself together just long enough for us to experience it. And that makes this exact moment in time an absolute masterpiece.